Hi everyone, I'm Piotr Zuraniewski representing TNO, Dutch organization for applied scientific research. TNO is maybe a little bit less known, so I will take a little bit chance to introduce ourselves. We are a pretty large organization, 2,500 people, working in a triangle of academia, government, and industry. Our mission is to bridge the gap between those three. We collaborate for knowledge development, for innovation with an impact. My talk touches information-centric networks. Shall I give 30 seconds introduction to it? Is there anyone familiar with ICN? Okay, some people, so I will do. Okay, ICN or Information-Centric Network, they say, well, we will get rid of IP, v4, v6, v whatever, and we will replace addressing with names. So you will ask the network, I want slash YouTube slash com slash presentation slash version 5, and the network will find it for you. There is also question that the devices, the forwarding elements may cache the content. So if this guy is requesting the same video as that guy, maybe you don't have to go all the way to this server, but it will be cached in the nearby router. There is encryption, signing, many things. I don't want to start a discussion whether or not this is the technology which will take over the internet. But the fact is that the developments are there. And, well, it's rather not possible to assume that a whole internet will be upgraded to handle new architecture or new protocol, right? What is currently happening is that those ICN domains or islands, they pop out all over the place, but they have to go through the network, the plain old good internet, which does not support them. When you hit a non-ICN network, well, you can, of course, set up a tunnel. You can use GRE or whatever and shuffle in your data packets into something which is actually handled by the routers all over the place. But typically, what they do now is they do it manually. So our idea was, well, SDN with its programmability can help you set up such things on demand. So you get this slash YouTube slash presentation request, and well, the network will set up this tunnel for you on your demand, right? The problem is that it would mean that SDN has to understand ICN protocol, and that's not happening. Like we've heard, or like you know, OpenFlow matches on a handful of predefined fields. They never heard of ICN, and you will have to wait some years to get it there. The packet structure of the NDN or ICN is pretty much complex. It's TLV inside TLV with everything which is variable length. That's really something quite difficult. So what we thought, well, let's not get rid of OpenFlow, although it cannot do its job in a basic form. Let's extend it. It's extensible protocol. And let's do like this. Let's match locally on the switch at the result of a BPF program. Because with this BPF, I can check this very complex packet structure, which I showed you on the previous slide. You can just traverse through all these fields and say, okay, I am matching on this part. That's relatively easy with BPF. Of course, you have to ship it somehow to the switch. So you need a messaging protocol or extension of OpenFlow to do it. That's also possible. And, well, you need the controller to manage those BPF programs. So once you have something like this, the situation is the following. You have your ICN traffic. Okay, it hits the border of traditional internet, which, well, this border understands SDN. This thing may ask controller, well, controller, what is the shortest path to, let's say, satisfy this ICN request. The controller can install the flows, and we are good to go. We can do the tunneling, we can do MPLS, we can do whatever we want. So actually we built it. We have 2 nodes in US, 1 node in Den Haag, our office, and yeah, we can do ICN over traditional internet. Very nice, but it's all software-based, and it yields right now 2,000 packets per second. And that's back to like, who remembers modems and analog lines? Yeah. Okay, so we thought let's buy some Netronome cards and shuffle in this eBPF stuff, because yeah, Netronome can do eBPF. It became a little bit more complex than we thought. Currently, we are experimenting with XDP, which was introduced 2 talks ago, because you can hook up with eBPF there. We are still in an exploration phase. How would it work? How would you rewrite? How would you tunnel with this XDP BPF machine? And well, we have also this SDN controller which manages it all. And how do we merge this all? That's the current research. Then the question is, of course, how far can we go with performance? Because there's hardware acceleration possibility, but we are not yet there. So, all in all, this framework with eBPF, well, you can match on anything, any field of any protocol. That's not what OpenFlow offers you nowadays, right? And if you have new protocol from all this machinery with controller and switch, to handle new protocol, you only have to change this little eBPF program, I think, to match on your new protocol. Of course, we need more performance, we need more functions, and let's say the dot on the horizon is that not only you handle any protocol, but you handle it at the line rate. And that's what we are, that's our ambition. Thank you.